All right, we are going to continue our talk about about triangles, and we're going to talk specifically about isosceles triangles and equilateral triangles. So our first topic is isosceles triangles. So if you remember from isosceles triangles, it has two sides that are congruent. So the isosceles triangle theorem says if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So if RT is congruent to RS, then angle T is congruent to angle S. So if the sides are congruent to one another, then the base angles are congruent. So if you consider TS your base, then those angles are congruent. The converse, remember the flipped, is also true. If the angles are congruent, then the legs are congruent. So if angle N is congruent to angle M, then LN is congruent to LM. So the sides are also congruent. So let's practice this. If I have this isosceles triangle here, and this is 78 degrees, and I see that my legs are congruent, then my opposite sides are also congruent. So this angle is congruent to this angle. So I know whatever this angle measure is, this angle is the same measure. So I can say 78 plus x equals 180. So let's subtract and we'll solve for x. So 2x equals 102, divide by 2, and x equals 51. So if x equals 51, I want to find the measure of angle C. Here's the measure of angle C right here. It is 51 degrees. All right, now let's add some little bit tougher equations here. The measure of angle H. Well, again, if I know my sides are congruent, then my opposite angles are also congruent. So this 8x equals 6x plus 18. So let's solve for x. I'm going to subtract my 6x to get it on the same side. So 2x equals 18. Divide by 2, and x equals 9. I'm not done because I want to find the measure of angle H. Well, if H is 8x, I'm going to plug in my x value, 8 times 9. So the measure of angle H equals 72. Put that up here on the line, 72. Okay, let's keep going. So down here, this one's a little bit turned. These were like put upright right there, but I'm still going to follow the same thing. If this is my my side lengths are congruent, the opposite angles are also congruent. So this angle is congruent to that angle. So this is considered the base of your isosceles triangle here. So this is x, and this is the same value x. So I know x plus 86 equals 180. Because it's a triangle, all triangles are 180 degrees. So we have 2x plus 86 equals 180. Subtract 86, and we get 94 equals 2x. Divide by 2, and x equals 47. 47. So I'm looking for the measure of angle Q. Q is x, so Q is 47 degrees. All right, let's keep going. Same thing. If my side lengths are congruent, the opposite base angles are also congruent. So 2x equals x plus 30. Subtract x here, and x equals 30. I'm not done because it's asking me to find the measure of angle M. The measure of angle M is x plus 30. So I'm going to plug in 30 for the x value, and the measure of angle M is 60 degrees. All right, let's flip it to the back. We're going to talk about equilateral triangles. So if a triangle is equilateral, then it's also equiangular. So if all the sides of a triangle are congruent, then all of its angles are also congruent. The same is true if it's equiangular. If all of your angles in a triangle are congruent, then all of your sides are congruent. So either way you say it, equilateral is equiangular, and equiangular are equilateral triangles. All right, so We know in an equilateral triangle, if all the sides are congruent, then all of the angles are congruent. So we can do this one of two ways. We can know, hey, if this is 5n, then this is 5n, and this is 5n. And we can say 5n plus 5n plus 5n equals 180. So 15n equals 180. Or we can say, hey, this is 5n, and I know if they're all the same, and they all equal 180, then 5n equals 60, right? Because all of these angle measures are 60. So we just need to figure out what multiplies by 5 to get 60, which is 12. So n equals 12. Any way that you put it, you'll get the right answer, because if you divide by 15 here, just a bigger number, it still equals 12. All right, let's look at this one. If all of my angle measures are equal, then I know that all of my sides are equal. So I know that 9r, this side equals this side. So 9r equals 5r plus 8. Subtract 5r, then 4r equals 8. Divide by 4, and r equals 2. Now, it says they don't want to know what r is. They want to know what VT equals. So if VT is 5r plus 8, then I'm going to plug in 2 where I see the r. So we have 10 plus 8, and VT equals 18. And it's not an angle, so I'm not going to put a degree there. It's a length, right? So it's either going to be centimeters, millimeters, inches, whatever length is, not degrees. All right, 2 more examples here. So same one as the first one above. If all of my sides are congruent, I know all of my angles are congruent. So if this is 2x minus 6, then this is 2x minus 6, and this is 2x minus 6. And if all of them are congruent, I know that they all equal 60 degrees, right? So I can create my equation based on that knowledge. 2x minus 6 equals 60 degrees. Add your 6, and 2x equals 66. Divide by 2, and x equals 33. So here, it's not asking us to find the angle measure. It's just asking us to find x. So I'm just going to plug in my answer here. 33 was your answer. All right, last one. All of my angles are congruent. Therefore, all of my sides are congruent. So these sides are going to be congruent to one another, meaning they're equal to each other. So y plus 10 equals 4y plus 1. Solve for y here. I'm going to move my y over by subtracting. So 10 equals 3y plus 1. Move the 1 over by subtracting, and 9 equals 3y. Divide lastly, then y equals 3. Okay, but it's not asking us for y, it's asking us for mn, and mn is 4y plus 1. So wherever I see that y, I'm going to plug in a 3. 4 times 3 plus 1. 12 plus 1 would be my answer here, 13. And again, it's not an angle measure, so I'm just going to put the measure 13. And you're good on to start practicing with equilateral and isosceles.